Free float is total float minus head event slack. So total float we have already found out, which is latest start minus earliest start. So that we already found out 5. So this will be 5 minus. Now we have to go to head event. So this activity is 1 2 here. So if the activity is 1 2, we will look for this 1 2. Head event is 2, and the head event slack will be 9 minus 4. That is also 5. So this becomes 5 minus 5, which becomes 0. Okay. So the free float is total float minus head event slack. Total float is 5, and if we go activity 1 2, this is activity 1 2, and this event 2 having the slack of 9 minus 4, that is 5. So 5 minus 5, it gives us 0. That's why we write here 0. Now when we go to next activity 1 3, we will find this total float is 0, and activity 1 3, here the slack is 1 minus 1 0. So this becomes 0 minus 0 form, and it is of course again 0. Similarly for 2 4, okay, our activity is 2 4. Our free float will be total float 5 minus head event slack. That means 2 4. This is 2 4. Head event slack will be, head event is 4. So 10 minus 5 becomes 5. This is also 0. For activity 3 4, okay, activity 3 4, total float is 8 minus 3 4 means we come to this 3 4, and head event is 4. So 10 minus 5 becomes 5. So the free float becomes 8 minus 5 is equal to 3. Okay. Next we go for 3 5. For activity 3 5, the free float is 0 minus, total float is 0 minus the head event means 5. So we go to 5 here. Here 5, for event 5, the event slack is 7 minus 7, which will be 0. So this becomes 0 minus 0. Actually this becomes 0. So next we go to 4 9. This is 4 9 here. Here this is 4 9, and for total float we have already found out total float is 5. Now for 4 9, the head event slack is 15 minus 10. So 15 minus 10 is 5. So it becomes 5 minus 5, 0. Next again 5 minus 6, 5 6, activity 5 6. Upon activity 5 6, the total float is 5, and the head event slack here 16 minus 11. So 16 minus 11 becomes 5, and this also becomes 0. In 5 7, here 5 7, the total float is 0, and for activity 7, this is the slack of event 7 is 0. So 0 minus 0 becomes 0. For 6 8, total float is 5, and for 6 8, the head event is 17 minus 17 is 0. 7 8, for 6 8 we have not completed it. 6 8, it will be 5. Now 7 8, 0 minus 0 is 0. 8 10, for 8 10, this will be 0 minus 0, and for 9 10, it becomes 5 minus 0, thus it becomes 5. Do you have any questions on how we have found out the free float?
Seven eight একটু দেখুন স্যার
কোনটা? 7 8. Okay,
7 8
fine. 7 8, in 7 8 the total float is 0.
Okay.
Okay, is it visible?
Yes sir.
For 7 8 total float is 0. Now the head event is 8. We go for head event 8. And 8, in 8 you see, this is 17 minus 17 is 0. So
Okay, sir. Okay,
in
sir.
7 8 this becomes in 0 minus 0 form, and thus it becomes 0. When you just find out how to solve what is the actual formula and what is the procedure, then everything becomes very easy. But this chapter, these problems are little lengthy, but this is easy actually. It takes a little time and very very high patience is required. There are lots of plus minus you have to take care of. Okay, so do we need to solve any more problems on this chapter? Otherwise we will go to part. All the problems will be on same scenario, on the same procedure. Do you need to solve more problems on it? And the part is also similar. So if we go to start with part, you will find this similar. So if you have no problem on CPM method, then next we will go to part. Okay, no questions. So now then we can go to part. Part means program evaluation and review technique. When when we have the deterministic completion time period of each activity, then we use CPM. But there are some cases where the completion time, absolutely sorry, the completion time is not properly given. I mean, it is probabilistic. For an example, for an example, suppose you are making a new product, you are launching a new product in market, uh, or you are finding out a new design. So the actual time period is not uh, deterministic. You know there is a time, if everything goes fine, then the minimum time will be required. So when the situation is most optimistic, then you know the optimistic time for a particular activity to be completed. Optimistic time. Okay, this is also denoted with A, either TO or A. Now there is a term which is called TM, which is called most likely time. So if you do uh, the work for a several number of times, the most likely time is this TM. This is also denoted as M. Now there is pessimistic time or TP. This is called pessimistic time. This is also denoted as B. Now when everything goes wrong, the maximum time that can be required for complete any activity, that is TP, T pessimistic. Okay, so from here, when these three datas are given, then you can find out TE, which is basically an weighted average. TE is the estimated time. So estimated time TE, which can be found out by A plus 4M plus B by 6. So maximum weightage is given on M, or the most likely time. So this TE is not deterministic, TE is probabilistic, and that's why these all things, optimistic time, most likely time, pessimistic time, all to be considered, and we will give more weightage on this most likely time. So the estimated time will be this. Now in this chapter we will find out if the estimated time is, say, x number of days. Estimated time we have found out to be x number of days, then our job will be to find out the probability of completion of the project in y days. Okay, we will solve it with an example, but first we need to know some terminology. Okay, so when we find out t estimated or te, then we will also find out the variance of each activity. Variance of each activity is given by sigma square, and that sigma square will be found out by Tp minus To by 6 whole square. This term is called variance, and this sigma is called standard deviation, which will be required later, but now we need to know the terminologies. So variance is sigma square, where sigma is standard deviation, and sigma square equal to Tp minus To by 6 whole square. Okay, now we have found out, when we have found out the TEs, and then any question?
Yes, sir.
Yeah.
Sir, the variance of each activity, we
Mhm.
can simply write, sir, sigma equal to Tp minus To by 6. Why in the square form?
Because if we find out sigma, that is standard, that will be standard deviation, and variance is also required for calculating this analysis. It is
Okay, sir. Okay, sir.
it is not only that standard deviation is only required, variance is also required, and from adding all the variance of all these activities you will get the variance of the whole project, and then by doing square root of that variance of the total project you get the standard deviation. When you solve
Yes, sir.
problem, then the ideology will be more clear. Okay, so now from these expected time estimates we can find out the earliest and latest time and the total floats, and thus we can find out the same procedure with CPM, and we can find out the critical path. So with this estimated time we will find out the critical path. In previous case the time is given, here we will first find out the estimated time for each activity, and then we go on the procedure to find out the critical path. Okay, when the critical path is found out, then that path will be denoted by Tc, which is T critical, and that Tc will be the estimated minimum estimated time to finish the job. Now objective of this analysis through part is to find a completion date for a particular event within specified date Ts. Okay, now we have to know some few more things. First we will learn the part procedure. Part procedure number 1, draw the project network. Number 2, compute the expected duration of each activity. Number 3, compute the earliest, latest times and total float of each activity. Number 4, find the critical path and identify the critical activities. Step 5, compute the project length variance sigma square, which is the sum of all the critical activities, and hence find the standard deviation of the project length sigma. Okay, and number 6, calculate standard normal variable z, actually not z, it will be d, standard normal variable d, where d is ts minus te by sigma. And then calculate normal standard variable, of course z, and d is just another uh, quantity, which is ts minus te. Okay, now uh, let us go to a problem and solve it, and then
So
we'll
D
discuss.
technique, sir.
Kunta, d is just another quantity. D is another quantity. D is just another quantity, which is ts minus te by sigma. Now this d will be required. Where it is required, how will you solve the problem, that we will discuss with a problem. Okay, now let us go to a problem first. Okay, so let us now go to this problem where the table is given: job, this is A, this is M, this is B, days, all these units are in days, and this is 1 2 This is 1 6. This is 2 3. This is 2 4. 3 5. 4 6. Sorry, 4 5. 4 5. 6 7. 5 8. And 7 8. Okay, so these days are given as 1 7 13, 2 5 14, 2 14, 26, 2 5 8 7 10 19 5 5 17 5 8 29 339 and 8 17 32. So the problem is given like this: the different activities and their optimistic time, most likely time, and pessimistic time is given for each activity. Now question is to draw the network and find probability that the job, sorry, not job, it will be project, completing in 40 days. This is the problem. So draw the network and find the probability that the project completing in 40 days. Okay, so when we find out this problem, we need to draw a table first. The table will be such as, here we'll write activity, here expected times, which is t optimistic plus most likely time into 4 plus t pessimistic by 6, and then for each activity we'll write the variance sigma square is tp minus to by 6 whole square. Okay, for each activity we will do the same. First for 1 2, second 1 6, third is 2 3, then 2 4, 3 5,
Hello,
5. Yes,
sir.
yes, yes, yes.
Sir, sir, camera is fixed, sir.
Uh-huh.
স্যার আমরা দেখতে পাচ্ছি না স্যার, ক্যামেরাটা এক জায়গায় স্থির হয়ে আছে।
Okay, okay. Sorry, sorry. Let me check. Okay, now I think you can see it.
Yes.
Okay. Okay. So now after 4 5, 6 7, 5 8, 7 8. Okay. Now you have to find out the TEs. So I think you can solve it by yourself. I'll just put the numbers here. This will be 7, 6, 14, 5, 11, 7, 11, 4, 18. I hope you all know how this number come in. this is the formula. We just put value of TO from here, and TM is here, and TP is here. So for all the activities, these three digits are given, these values are given by 6. So this will gives you this number. Now here also, for TP and TO given for all these activities, and thus you just put it here and you will get the answer. And this is 4, this is also 4, this is 16, this is 1, this is 4, this is again 4, this is 16, 1 and 16. Okay, you can calculate yourself. I am just putting out the values so to complete it in time. Okay, this is a very easy one. You just simple calculation, put it in the calculator and you will get the values. Okay, the formulas are given. Now if you do so, then you can draw the project network with this TEs, as we said in the procedure, that you can draw the project network with help of TE. The process is similar with CPM. So if we draw the network from 1, there will be 1 2 and 1 6. From 2, that will be 2 3 and 2 4. And 5 starts from 3 and 4. From 6 it goes to 7. Now from 5 and 7 we get 8. Okay, this is the network. Okay, now we have drawn the network, and if we do analysis and find out the total float, then you mark the total float is 0, and that path will be your critical path. That you can do it. Just in previous class we have learned how to draw the how to find out the total float and how to find the critical path from it. So here I'm not repeating that, I'm just marking it, the most lengthiest path, I'm just marking it. You do it in home, solve more problems in home. So that will be the critical path, and the time analysis will be starts like this. On critical path the times will be same. Okay, so now we are done, and these durations are like this: 7 6 14 5 11 7 4 18 11. Okay, so this is the network you have already learned. Now the project length variance will be calculated from the critical path. So we know the critical path is 1 2, we'll write C beside it, 2 3 on critical path, 3 5 critical path, and 5 8 critical path. So these are the path is 1 2 3 5 8. So these four paths are marked. So these are the variance of these four different activities: 1 2, 2 3, 3 5, and 5 8. Okay, now so the project length variance will be the summation of these four paths. So the project length variance, which is equal to sigma square, will be equal to 4 plus 16 plus 4 plus 1, which is 25, and thus the standard deviation we get is 5. Okay, so we get our sigma as 5. Now we'll go into the last stage. So the probability of the probability that the project will be completed in 40 days is given by P z less than equal to D, where D is equal to Ts minus Te by sigma. So Ts is given by 40, that is the target. Te is 36 and sigma is 5. So this becomes 4 by 5, which is 0.8. Okay, so D becomes 0.8. So now this P, which is Z less than equal to 0.8, this is a probability distribution, and which is written as 0.5 plus phi into 0.8. Now this phi, this is the formula. Okay, this is the formula. Now this phi 0.8, this to be taken from a table. This table will be provided on exam. This table will be provided on exam, and from that table you need to find out this value. So here on this problem, this phi 0.8 is given as 0.2881. So here you just put the value 0.2881. This will be given with problem. Now this will become 0.7881, or that means 78.81%. So you will write the answer if the job is done or the project is performed 100 times, if the project is performed 100 times under the same conditions, there will be 78.81 occasions the project will be completed in 40 days. Okay, so is the procedure clear to you? Any questions?
হ্যালো
Yes, please.
স্যার লেন্থ ভ্যারিয়েন্সটা একবার বলবেন
কোনটা?
প্রজেক্ট লেন্থ ভ্যারিয়েন্স
Project length variance. Look at this table. We have drawn the project network, and then we have found out the total float. Then we can find out the critical path. We'll look at this critical path. These 1 2 2 3 3 5 and 5 8, we have found out the critical activities. Now we mark these critical activities on this table, and now we have found out the variances of these critical activities. So this for 1 2 path, this is a critical activity. We have found out its variance. 2 3 is another critical activity. Okay, this belongs to critical path. So we have marked all these variances. Those activities are on critical path, so we are finding out the variances of critical activities separately for each activity. Now we will add them up. We will add the variances of each critical activities. We will sum up the variances of each critical activities, and then we get the variance of the project, the whole project. This is the project length variance, sigma square, which is 25. Now standard deviation is sigma, which is 5. Okay, is it clear now?
স্যার
Yes, sir,
3
clear.
হেডটা কত স্যার? স্যার 3 হেডটা কত স্যার?
কোনটা?
ওই যে 3 যে বক্সটার মধ্যে কত
3 boxটা 21 21.
ওকে স্যার।
Hello,
20
sir.
Yes.
আচ্ছা 7টা স্যার 7 8টা
হ্যাঁ, কোনটা
7 8টা
7 7 7 7 8. This latest time is 18 and earliest time is 17.
ওকে স্যার।
On triangle it is 18 and on square it is 17.